Alright, hello everyone. Today is 17 February and we're back to the daily LeetCode challenge. Let's get started. Okay. Construct smollett num on di string. You are giving an index 0 string pattern of length n consistent of the character I, meaning increasing, and d is decreasing. A zero index string num of length n plus 1 is creating using following condition. The digits 1 to 9 at most use at most 1. Okay, so let's have 9 number. If pattern I equal to I, then num e. If pattern I, then num I, the current will less than the next one. And if it's d, the current will greater than the next one, which is degree and degree. Okay. Return the lexicography smallest possible string num that meet the condition. So the pattern here is y I d I d d d. Right? So the output here 1, 2, 3, 5, 4, 9, 8, 7, 6, and dice 1, 2, 3, and 4 must have that num which is high at in this we must have is the some possible value of number are 2, 4, 5, 1, 3, 5, and 1, 2. It can be proven that one is the smallest possible. Oh, it's not possible because okay, this is using more than one. Okay, so the next one is D, D, D. The output is 4, 3, 2, and 1. Some possible for okay, so it's still lexicographical smallest possible. Yesterday we using the backtracking and the gritty, right? So let's go with this one. So it's the smallest, right? So the smallest have to be 1 to 9. Index is far from 0 and length will be plus 1 here. There will be plus 1 here. Since we have to decrease this number, it makes sense. So it starts from increasing, right? Increasing n. Why this is d. Okay, so starting from here, this is okay. So this is the starting point. One here, here, and here, and then from here we decreasing, increasing back, and decreasing here like this. Okay, so the first number is not attached to this one. Okay, same like this. This is decreasing over here. We can start from 3 or even we can start from 1, but because this is degree, so we have to going down. We let's see. I'm thinking of backtracking or something, but let's see the logic in here first, shall we? So we so the first thing is the pattern and the output. The output will equal to length of the pattern plus 1. This is the first thing, right? This is the first thing. So we will depend on the pattern to define the output. If we make it step by step, so the pattern technically we can start with any number, right? So how about we start with the smallest one? We're gonna do kind of greedy. We start with number 1. So if the increasing, we know it has to greater than, so it can be 2. Next, it can 3. Next, why we don't put it 4, right? We can, and then decreasing. This will this. So we have to moving back to this to update it to 5, and then go here to update it, and then we continue to going with this decreasing. We definitely can reach it to 6, right? And then 6 decreasing to 5 is not good, right? So we have to going back to make it 7, so we can decrease to 6, and here is 5 is not good. We have to go back and then go back. Yeah, it's kind of hard to doing this one. Okay, so how we gonna know? How we gonna know? Even with the, yeah, or how about we know how many degrees? For example, here I have 1, 2, 3, 4, 4 degrees and 4 degrees. So if we have some way to redict it first, or how about we going backward? Okay, let's think to going backward. So even this D I D I D D D. So we're gonna have one of the number, and the last one we want to make it as big as possible, right? Is it that what we want? Is the smallest? Because it's only have one time, so we want the biggest one will be out here, and then we're gonna squid it 7, decreasing here, decreasing, so can with 8, 9. Or we can do 2-pointer in here. Can I do 2-pointer? Nah, this one I don't think that we can use 2-pointer as well. Because the constraint here, for example, at this moment, this will depend on the number before and the after as well. So we cannot do that one. So one thing that I'm sure is we're gonna grid the on the first point. We want to make it smallest, right? So if it's increasing, we can going up, or if we cannot, we can go back, we can increase to 2. But how about if this one is decreasing, right? There's so many ways that I have to going back with something that I know. 4. Go to 4. Right? But the order is matter. The order is matter. Going from backward, is that easier? No. Wow, this is hard. Mm. Okay. What I know is only use one time, right? So it mean that 1, 2, 3, 4, 5, 6, 7, 8. So there will be 9 digits using in here. And 4 of it will be in degree and will be right. So I will have 9 position to place. How can I place the first one? So because the first letter is increasing and there's a 9 position, right? There's 9 positions. So my number will use all of this at least 1. Even the pattern length is ace and consists only I and A. Pattern length is A only because it cannot going out. Right, so definitely there can be a brute force to try everything, like loop everything again, and it's not too bad to do the brute force. I will try to do a brute force for today. But let's see, is there any other better way? Because the constraint is too little, so I think backtracking on the brute force should be good. So if I thinking in really naive way, I will say, okay, since I want the first number is the smallest, I will place the first is increasing. I play the second one here. Second will be here. 3 here. Here. Definitely it's go with 4. This is my logic. It cannot go anywhere else. But when it decreasing, I have to decrease to number 3. I will have to visit it. Alright, 3 is already in. So I cannot use 4 in here. I cannot use 1, 2, 3 or 4. So I have to go back. So how can I go back here? Right? There's no way that I cannot go back here. Is there any way I can actually going back? If going back, is that backtracking? Thinking this way in the tree. Okay, so we gonna have first position have 9 way to go. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Right? So if we start with 1. And the next one, the one is increasing. The first one will increase because it's the increase. So there will be 2, 3, 4, 5, 6, 7, 8, and 9 here. Because I always want to go with the latest. So I go with this. And it's gonna be, they're gonna have 2 to 3 to 9. This is in 3. And this is in 3 as well. Let's have 4 to 9. So increase, 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 and let me move this one. And, no, this is not increase yet. This is increase. Okay, let's go with the moment here. Now it's in 1 time, 2 time. Okay. Yep. 5 to 9. Alright. Wait, what? 1, 2, 3. Increase, 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 decrease. Okay, so let's capture at 3, 4, 5, and order. So we select this to increase to 4, and we have 5. Hello. we still good here? Are we still good here? Yeah, we're still good. Okay, cool. So we 5 to 9, but this time we have to decrease it, and we don't have any number left, so we have to going back here to go to the next one. Alright, so we have 4 to 9, so we increase, move here, select 4, and is good. We decrease it, we select number 4, and then we increase. Now increase, we have 6 to 9, right? Then we go down. Look good to me. It look good to me. So we stop whenever the length is greater than. Yeah, there will be the base case here when if this is I, when is I plus 1, length of the pattern plus 1. Okay, to be honest, I don't know how to code it out. Even this is an idea, right? But for us to backtrack it until yeah, we have to moving back. So let's say the output, so probably like this, return a result, but at the same time we gonna have the visit. Yes, this is brute force and using backtracking. So I will backtrack with I and yeah, how about we put the results in here to build it up. Yeah. If I pattern plus 1, return something. Yeah, I want result to have 1 at the first 2 to make it the same length with I, D, right? So 1 is here, 2, 3, 4, 2, 3, 5, 4, 9, 8, 7, 6. Yeah. Okay, let's move it here. move it there. Okay, and got the base case. So j in rank of I and length of the pattern if the j need to have one to point back, right? Um, yeah, the starting point. We go moving up. We gonna need to add it. So right now is blank. Yeah, the first one. If pattern j equal to I. Else. If increase so I. Uh, no, I don't know how to code it out. Yeah, that's sad, but oh well, that's how it go. 28-minute solution. Brute force. Optimize with bit masking. Oh my god. Regulated brute force using stack. Damn, this one can using stack. Gritty sliding window, and it can using sliding window. Wow, this have a lot of solution. Yeah, 7. Oh my god. Okay, I think I'm going with the LeetCode guy. But yeah, thank you for watching today. This third time in the week. I did not. I didn't make it. It's okay. It's a long progress. Alright, hope you enjoyed the video and see you tomorrow.